Welcome back, everybody, for part two of the ANSYS eigenvalue buckling tutorial. So in the first part of the video, I went over how to set up the model and apply the boundary conditions, mesh the model, and then we ran our static structural case for the pre-stress input for the eigenvalue buckling, and we ran our buckling analysis, and we got our modes based on the load multi. This is the load multiplier. So I'm going to talk a little bit about the results here. So if you recall from the first video, we set up our boundary conditions so that x, y, and z were fixed, and the rotation about z and y was fixed. And so what that does is it simulates a pinned beam constraint. So if we look at some theory, for a beam that is pinned on either end, you get a K factor here of 1, so your effective length is 1. And what that's saying is you have a free rotation, but the translation is fixed. So we are only allowing the rotation free in the x direction, or about the x-axis. And so these are the results here from the hand calc. The first, based on this geometry, we predict the first mode to have a critical load of 37,643 pounds. And how I got that from the model is I took the force reaction, because if you remember from the first video, I applied a displacement to the top of the beam in the negative y direction. So I applied a 1 mil displacement. So our force reaction is 686.52 pounds. And if I multiply that by the load multiplier, you get 37,572 pounds. And round it up to the nearest pound, it's 37,573 pounds. And that is within 0.2% of our hand calc prediction. And then I've done the same calculation for the mode 2. So mode 2 for the fixed rotation, I'll show you what that mode looks like. That actually corresponds to mode 3 in our analysis. And you can see here, it looks like the second mode for this is a pinned constraint. And now you'll see that there's another mode here about the z-axis. And this one is the fixed constraint mode. So this would be mode 1 of the fixed constraint boundary condition problem. And that's because we fixed the rotation about the z-axis. And there's another rotational degree of freedom here that this bar can bend in. And so these actually are theoretically identical. So if you have a K of 0.5, this is the Euler load prediction for that mode. So mode 1 is going to be equal to mode 2 for a K of 1. And you see that here. Based on the hand calc, K of 0.5, these modes are the same. And then the error from ANSYS This is the ANSYS predicted buckling load, and it's within 0.7%. And again, if we want to animate this, we can see how the mode shape looks like. And then again, the mode about the x-axis here. This is the second mode of the pinned constraint and the first mode of the pinned constraint. So yeah, that's how you run a pre-stress eigenvalue buckling problem in ANSYS of a simple beam, and then we've matched the results with our hand calc. So thanks for watching, everybody, and hopefully you enjoyed the video. And I'm looking forward to making more videos for you guys.